Unicode! Not to be confused with a unitard, which is a tight-fitting one-piece garment of stretchable fabric that covers the body from the neck to the knees or feet. Unicode is an international standard that encodes characters so they can be seamlessly processed and represented regardless of the platform. Unicode represents human language and other weird forms of communications like freaking emojis and stuff like that. Did you know emojis were created to save data? Life. It's crazy. Every character in the standard is assigned a unique number. Strings in Swift are composed of Unicode Scalars, not like the one in your bathroom that you hate. Unicode Scalars are 21-bit numbers that represent a specific character in the Unicode standard. This guy, U0061, for example, it represents the Latin small letter A. It represents A, you know what I'm saying? Or freaking U1F60E represents the smiley faced emoji with sunglasses, or as Australians call them, sunnies. This text right here is the standard way of writing a Unicode character. It's kind of weird, right? Like what even is that? You know, the 1560E is a number written in hexadecimal or base 16, which I feel like we covered, but if we didn't or I didn't, that's on me. But if not, you'll see what I'm talking about in a cool minute. So let's do let Casper equal U1F. Or I totally have this memorized. I didn't look this up on the internet. And ghost. How do you spell ghost? Like that? See, that's nice. I like that a lot. We used a little bit of a new syntax to create a string, huh? The quotation marks, these look familiar, but what the heck is going on inside of them? That is definitely not a string literal, am I right, sister? And that's because it's not. The U with the braces, this syntax, represents the Unicode scalar whose hexadecimal number appears between the braces. We just assigned Casper to be equal to the character representing the ghost emoji. It's truly a classic emoji in my opinion. Speaking of ghosts, shameless plug, hit me up on the Snap. Oh, you know what would be freaking cool? If you guys sent me snaps with your code. That would be dope. Anyway, how does this Unicode stuff relate to more familiar strings? Every single string in Swift and every single string known to man is made up of Unicode scalars. Every character in Swift is built up from one or multiple Unicode scalars. One Unicode scalar maps onto one fundamental character in a given language. The reason I say that characters are built from one or more Unicode scalars is because there's also these things called combining scalars. I know. Let me explain. Do you know what an acute accent is? It's this little guy, man. It's this little guy above letters, you know? So, U plus 0310 represents the Unicode scalar for the combining acute accent. And what the acute little guy, what that does, this scalar is placed on top of, it's like the guy that goes on top of letters. Like if this A had an accent above it, that's what this is. This scalar is placed on top of or combined with the character that is before it. So let's take this A that I was talking about and let's create an A with a little cute guy on top. So let a cutie equal, and we're gonna pop in the same syntax that we just used, just with the right numbers here. See the A with a little cutie in the results bar? This is getting kind of complex, and I know, but you asked for it. You said, Nick, give me the knowledge. And I said, anything for you, baby. Every character in Swift is an extended grapheme cluster. An extended grapheme clusters are sequences of one or more Unicode scalars that combine to create a single human-readable character, which is what we just created. We can break down the cutie A into its two base scalars, which is the letter, this guy, and the accent. And as we've stated a million times, Swift is smart. We can see all of the Unicode scalars in a string. Let's take a look at the stubborn guy we created. We'll use the Unicode Scalars property. That's just basically one of these things. And the Unicode Scalar property holds all of the scalars that Swift uses to make the string. So if we did a for loop for the stubborn guy and did Unicode Scalars property, we could print scalar.value. And this scalar is it's just the iterator. It's nothing special. So look at all these, look at all these numbers that pop up. What the heck are those? This video is really getting long, and I swear it'll end and it's gonna blow your mind. So Unicode Scalars property holds onto data representing all of the Unicode scalars used to create the string instance stubborn. Each number in the console right here corresponds to a Unicode scalar representing a single character in the string. So this is a single character. These aren't hexadecimal Unicode numbers though. Instead, each of these numbers is represented as an unsigned 32-bit integer. The first number here, 72, corresponds to the Unicode scalar value of 0048, and that's basically an uppercase H because of hello, stubborn David. Computers are crazy, fam. I take a breather after this video, recoup, get all your senses together, and join me in the next one. Subscribe and try to wrap your mind around all this because I know it's nuts. Nuts.